Hi, today I want to talk to you guys about zero and negative exponents. So first I want to go through the patterns that you see on your notes there. So if you want a calculator, get a calculator, start trying it on your own. But I want you to just look at some patterns here. Remember that 2 to the 4th means 2 times 2 times 2 times 2, which is going to give you a total of 16. And then 2 times 2 times 2 is 2 to the 3rd, which is 8. 2 squared is 4. Now I don't want to go any further. Alright, just look at it. Look at our pattern. As our exponents go down, what happens to our answers? 16 to 8, 8 to 4. You should see, well, this is divided by 2, and this is divided by 2. Hopefully you're clever enough to figure out it's dividing by 2 because look what our base is. Our base is 2. Alright, so start thinking what's going to happen to our second example. What do you think those numbers are going to be divided by? So keep that pattern. Don't guess. Keep that pattern. If you take 4 divided by 2, what you're going to get is 2. 2 to the 1st power is 2. It's like having 1 2 there. Alright, now this is where it gets crazy. Keep the pattern. Divide by 2, divide by 2, divide by 2. Keep dividing by 2. What's 2 divided by 2? It's not 0, it's 1. Alright, check it on a calculator if you don't believe me. Take 2 to the 0 power. What do you get? There is a pattern. Every single time it's being divided by 2. So now think, if I keep up with this pattern, divide it by 2 again, so I'm going from 2 to the 0 power to 2 to the negative 1st power. It's not a negative number, not at all. You're taking 1 divided by 2, and guess what? Oops, sorry. You've got 1/2. Keep that pattern. If you divide it by 2, you're going to get 1/4. Divide it by 2, you're going to get 1/8. Divide it by 2 again, you're going to get 1/16. So look at it. What patterns do you notice? I'm hoping that you notice 2 to the 4th and 2 to the negative 4th, they both have 16 in them. 2 to the 3rd and 2 to the negative 3rd, they both have 8. 2 squared, 2 to the negative 2nd, they both have 4. 2 to the 1st, 2 to the negative 1st, they both have 2. And then that 2 to the 0 wasn't 0, it was actually 1. Alright, so I want you to look at the next pattern here. Let me change something real quick. Okay, so 3 to the 4th, 3 times 3 times 3 times 3 is actually 81. 3 times 3 times 3 is 27. 3 squared is 9. Now I asked you to think about what we would be dividing by. 81 to 27, 27 to 9. Hopefully you're seeing that we're dividing by 3 every time. And again, why are we dividing by 3? Because our base is 3. If we had a pattern of 5s, what do you think we would divide by? 5. Alright, so keep this pattern. If we keep dividing by 3, 9 divided by 3 is 3. Keep this pattern. 3 divided by 3 is 1. Keep the pattern. 1 divided by 3 is 1/3. Divide that by 3. 1/3 divided by 3 is 1/9. Look above. Look at the beginning. Hopefully you guys can see a pattern here without even dividing. You should know that the next one is going to be 1/27, and the next one is 1/81. Again, if you look, your 3 to the 4th and 3 to the negative 4th both have 81. 3 to the 3rd, 3 to the negative 3rd, both have 27. So look at it. What's the difference? Every single time that they went into the negatives. What kind of numbers are they? They're fractions. When you have a negative exponent, your answer is going to turn into a fraction. It all went 1 over that number. And then look at our exponent of 0, at no time is this ever going to reach 0. All right? These are exponents, part of exponential functions. Part of that, which we are not going to get into, is that it'll never hit 0 and it'll never go into the negative numbers. All right, so to go back to your notes here, 0 is an exponent for every non-zero number a. So when your variable is anything but 0, all right, and you raise it to a power of 0, it's always going to be 1. So 9 to the 0 is 1. 48 to the 0 is 1. 5,724 to the 0 power is 1. So now when we have a negative exponent, and what that means for every non-zero number a, so whatever the variable is not 0, okay, it's an integer, it's a number there, and then an integer n, so whatever it's being raised to, either a positive or a negative, but here we're talking about negatives. So we've got our variable a to the negative n power. It's always going to be 1 over a to the n. If you look, we put a 1 over it, and that n turns into a positive. So for simplifying exponential expressions, all negative exponents need to be rewritten as positive exponents. And then one thing that you should know by now is you can't have a fraction within a fraction. All right? But we are going to change all of our negative exponents to positives. So here's an example. This isn't in your notes. So 5 to the negative third, what you should have noticed, put it over, oops, my bad. Hang on a second. Alright, so if we put a 1 over 5 to the third, and right now I'm not worried about simplifying it. Same thing, 2, what's it going to be? 1 over 8 to the fifth. These are the things we're going to look at tomorrow. And then when we are evaluating an exponential expression, it helps to simplify the expression before substituting the given values in for the variables. We are not going to do this here. This is something I need to do with you, but just to give you a preview, tomorrow I'm going to give you problems like this. 1 over ab to the negative second power when a is negative 5 and b is 3. This is stuff we're going to do tomorrow, all right? But it's easier to simplify the expression before substituting in. So we are going to practice and practice and practice tomorrow. See you then.